This is problem number 18, and it is a problem about bonds. So a couple of things to consider. One, it's very important to know your vocabulary. And two, there's a few wrinkles in this problem that we're going to need to iron out. The first here comes from the second bullet point here, or the number 2 in the list. It says the ratio of the semi-annual coupon rate R to the desired semi-annual yield rate I is this value 1.03125. So what they're saying is R over I, or the coupon value over the interest rate, is equal to this. And we're going to see how that's helpful in just a moment. And then we have this factor here. And this is just a crafty way of them giving us our present value factor. V is the reciprocal of 1 plus I, so v to the n is our present value factor there. But we are dealing with semi-annual coupons. So that means for every 1 year, we're going to discount back 2 periods. So for n years, we would discount back 2 periods for each one of those years. So we're going to square both sides and use a slightly modified present value factor, which will be 0.3468. So there's our present value factor for semi-annual coupons. And then let's talk about vocabulary. When we break down the bond formula, we have price is equal to the face value of the bond, or the par value, and face value, par value, the same, times the coupon rate, times the present value of an annuity, plus the present value of the redemption value of the bond, which is usually the same as the face value. But in this case, they've told us that the present value of the redemption value of the bond is this 381.5 right here. So what we're going to do is we're going to take this formula, our generic bond formula, we're going to plug in the information that we have, and then the answer is going to follow. So, face value, 1,000, times coupon rate, R, we don't know, times present value of an annuity, that is 1 minus v to the n over I. So we can see our R over I construction right there. But remember, this is semi-annual coupons, right? So instead of v to the n, we're going to do v to the 2n. Plus, present value of the redemption would be, well, it was given to us. So it is 381.5. Now we can plug in values for R over I and for v to the 2n, and that should do it. 1,000 times R over I is the same as 1.03125 times 1 minus v to the 2n, so 1 minus 0.3468, plus the given present value of the redemption value of the bond. So we plug all that into our calculator, and we get 1055.11 or something thereabouts. So the correct answer here is